Hey guys, Happy New Year. Let's hope. Anyway, I rather doubt it, but I guess we could still be at peace and remain happy regardless until doom strikes our neighborhood like it has for so many others. Uh, anyway, hard to really put everything into perspective. But anyway, I left you hanging yesterday, and so here ISWA stayed up. And here's these three are synced. 1, 2, 3. This is the Z cat looking straight down on the planet. Remember we left off around 12:31, 23:30. That's when it ended. So this is all stuff that happened after that big sploosh that I showed you on the geospace. There's the Y cut that's looking straight across the planet. It's like a cut plane. Think of an MRI making a slice down through the magnetosphere from top to bottom, and we're looking sideways. These blue lines are the interplanetary magnetic field lines, which we still got quite several stacking up in front of the planet from time to time. But basically, this large prominent bow shock, which in and of itself is about 5 Earth radii thick. So each Earth radii is 4,000 miles. These are Earth radii represented here. 5, 10, 15, 20. So even that bow shock itself, well, out here it's, oh man, maybe 15 Earth radii thick. But out here at the point of attack or defense, it's about 5 anyway. 20,000 miles, that's pretty lot of density. I'm just riffing here, guys. Honestly, I don't have a script or anything. Just looking at this stuff together. Solar wind speed, I noticed it got up to like 8 something a couple times, and hit quite a few sevens. As you can see, it's fluctuating quite a bit, and all this data that we're getting to formulate these simulations is coming from these GOES satellites, 13 and 14, and I think 15's up there. Of course, the GOES 16 and 17, those are weather satellites. And the Himawari 8, which made several videos with, showing you that planet that crossed into and below the geosynchronous orbit satellite range. That occurred around October 16th. And also October 16th, there was a large planet that crossed past this L1 Lagrange point, because the ACE satellite, ever since I started making videos, which is out here 930,000 miles in front of the Earth, and the Discovered satellite, they both reside in the same area. ACE went up around in the late 90s, 95 or 97, and Discover about 20 years later to replace it. They both record the same solar wind data. And on the ACE one in particular, not on the Discover, I was getting 3-4 hour gap, 5 hour gap, 6, 7, and it got to be a 9 hour gap that began in January or so, right around when I first started making videos again. And on October 16th, coincidentally, all of a sudden there was a 9 hour gap on the 15th, and then there was no gap on the 16th, and then the gap started showing up on this side, which I determined was a data gap, which we're able to do by pulling up the ground tracking station plots. And this is for ACE. Not getting too many gaps on ACE, but now we're getting them on Discover, which is kind of strange. Now remember yesterday when the sploosh occurred? It happened around 23:20, and I showed you this Discover. There was no gap here then. I showed you everything. And here it is here on my video. If you click that box down on the right, lower right, to enlarge this thing, you'll see I got the timestamp up here. That's when I indicated the BZ, the BZ, and the BT magnetic angle components measured from the sun. Zooming to the Earth. But anyway, between the sun and the ACE and Discover satellites anyway. So this, we had data running all the way up until well, it was well past there, and now for some reason well, anyway, for some reason they deleted it, and they're representing it as a data gap. So here's the Discover ground tracking schedule, and I got it up on it 3 days. And there's that big gap. If you click that lower box to the right, you'll probably be able to see this better. But it's showing the data gap from 12/31/2210 UTC to 01/01/534 UTC. So that's like 7-hour and 24-minute gap. So I don't know. That's kind of strange to me. They might be playing around with these gaps, data gaps, for whatever reason. I don't think there would have been any other reason prior to this event that we recorded yesterday, when the BZ and the BT components became intertwined for, it was 28 minutes or so. It's in the video I made yesterday when the sploosh happened. And that was all visible, at least up until here. It looked like, well, let's see, that recording ended on 23:30, so it was at least visible up till real close to double aught on 01/01. So why they're hiding this, I don't know, or why it disappeared. Oh well, enough of that. That's getting boring. So let this run play through for you. You can watch it. And these two are synced. So you're seeing we're getting 01/01/19 data in here. And this is like the false bow shock in the back that's helping to ward off all this energy coming from Nemesis. I did notice, well, other than the magnetopods getting pretty whacked around, this here, this high energy piling up on this upper north-northwest or west-northwest quadrant shown on the magnetopods. I have never seen that before, so that's something new. And it's showing up on the geospace too, on the pressure cut. Here's the Y cut. Once again, it's same data we're getting from those geosynchronous satellites. It goes 13, 14, and 15, but it's being run through a different simulation. It's a geospace program, and University of Michigan puts this out. So that's what I'm talking about there. I never seen that before. So we're getting a lot of energy piling in from this area. This is pressure cut for the last 3 or 4 hours. Here's the density. So you can see we got a lot of density out here. Notice there was a few waves coming through. There they are. So that's stuff being slung at us from that big planet out in front that I was telling you about that crossed Ace on the 16th and been headed this way ever since. Because then those data gaps started showing up on Ace after the October 16th when that big planet crossed and was headed on the way toward Earth. So it had to be because they were showing like 8-9 hour data gaps on Ace. And you can go back and check the videos around anytime around October 16th. And you'll see, and just check out my hypothesis number 1 that I've been posting below all the videos. Here's the velocity. See, it's all coming down. We're solar wind speed's coming down. The density's staying up though. It looks like it's coming down on Discover. On Ace, yeah, I guess it looks like it's coming down here too. Look at all the fluctuations. I think this is due to, well, the instability in the magnetic field, basically. You can see the BZ and the BT components split apart again pretty much. But look at the fluctuations. I don't know, guys. I don't know. It's worth monitoring. So let this play through. You can check it out. Here we are toward the end of the run. See the magnetopause getting pretty well swirled around. Got a lot of energy coming from behind. Basically, we're still running a pretty much steady connection between the sun, dominant toward the sun side because it's below the 180 on the phi angle. That's the blue angle here. It's pretty much staying basically below the 180 except on around in between the 10 and 11 o'clock hours. You see it jumped way up. Let's see if we see anything over here. There's about an hour lag between what happens out there at the Lagrange point 1, 930,000 miles, and when it hits the these ISWA simulations. And let's pull this one through a few times. So watch the blue field lines. I noticed some people are trying to say there's a planet out here. I don't think there's no planet out there, and the Nemesis isn't out there. Nemesis is obviously way back here somewhere, because there's the Nemesis blue interplanetary magnetic field lines trying to creep up the middle all the time. And that's what their bow shock's been fighting, the false bow shock in the back. And they've gotten as close as 20 Earth radii from behind the planet. Looks like the magnetosphere is holding its own. These polar cap field lines, even though they're not as many, they're getting pretty dark at times. And when they have to, they close. They expel all this plasma. But this, look at that. That's purple. Purple. That's high energy plasma, and it looks like it's hanging around quite a bit. That's why probably we have this stuff showing up over here. As you can see up here, there it is, hanging up in that west-northwest shoulder area. So there you go, and watch out front. I noticed a couple of squirrely lines there. Well, I run out of time. God bless. Peace.